2020 rover animation. The sequence begins with the Mars 2020 rover. This robotic explorer was engineered to study the Martian surface and prepare the groundwork for the first ever sample return campaign.
Rover driving animation. The rover moves across the terrain using autonomous navigation. Its hazard detection systems and onboard mapping tools allow it to travel safely through the rocky landscape.
Sampling and caching sequence. One of the rover's most critical tasks is collecting rock and soil samples. Using its coring drill, it extracts cylindrical pieces from Martian rock layers. Each core is placed inside a sealed titanium tube to protect it from contamination. This caching system is one of the most advanced technologies ever sent to another planet. These tubes will eventually be retrieved and brought back to Earth, where scientists will study their chemistry, mineralogy, and potential clues about past habitable conditions, and possibly ancient microbial life.
Tubes on the surface. After sampling, the rover deposits the filled tubes at planned locations on the surface. These drop sites act as retrieval points for the future lander and fetch rover. In parallel, NASA and ESA prepare the Earth Return Orbiter. This spacecraft will travel to Mars, enter orbit, and later capture the sample container launched from the planet. It will then set the course back to Earth, completing the interplanetary transfer. Next comes the Sample Return Lander, which begins its cruise toward Mars. This lander is designed for precision entry, descent, and landing, ensuring it touches down close to the rover's designated drop zones. Rover watching the lander arrive. As the lander approaches, the rover observes its arrival. This coordination is essential because the coming stages depend on accurate positioning and timing.
The lander completes a controlled touchdown on the Martian surface. Inside it are two mission-critical systems, a small fetch rover and the Mars Ascent Vehicle, the first rocket ever intended to launch from another planet.
Lander deploying solar panels and fetch rover. This rover's main job is straightforward but challenging. Locate the cached sample tubes, collect them, and deliver them back to the lander. The fetch rover navigates the terrain using onboard sensors to find the tubes placed earlier by the Mars 2020 rover. It retrieves them one by one and transports them to the lander's sample transfer system.
Finally, the lander's robotic arm takes over. It transfers the collected tubes into a sealed sample container, which is mounted inside the Mars Ascent Vehicle. This container will later be launched into Mars orbit, marking a historic first step in returning physical material from another planet.
Mars Ascent Vehicle launch. With the samples secured inside the container, the Mars Ascent Vehicle prepares for launch. This small rocket carries the collected material and lifts off from the Martian surface, marking the first ever launch of a spacecraft from another planet. MAV launch and orbiter tracking. As the rocket climbs through the thin Martian atmosphere, the Earth Return Orbiter begins tracking it. Precise navigation is essential here because the orbiter must intercept the payload once it reaches Mars orbit. Orbiter captures the sample container. The Earth Return Orbiter performs a controlled rendezvous maneuver. Using a capture system developed by ESA, it safely secures the sample container, ensuring that it remains isolated from contamination throughout the process. Once on board, the container is transferred into a specially designed containment module. Here, it undergoes initial processing and verification to ensure the
Mars 2020 rover will initiate a long sought-after mission of returning Martian rocks and soil to the Earth for further study. The Mars sample return mission is a high priority not only for the scientific knowledge it will provide, but also the opportunity it presents to tackle a difficult technological challenge. Remember, Mars 2020 is going to have the first Mars helicopter. The Mars sample return will include the first ever rocket launched from another planet.
Once on board, the container is transferred into a specially designed containment module. Here, it undergoes initial processing and verification to ensure the integrity of the seal. The outer housing and transfer mechanisms are jettisoned before leaving Mars to minimize mass and simplify the return sequence.